Hey there, it's Miss B, and in this video we are looking at the Unit 1, Lesson 13 Cumulative Practice Problems for Illustrative Math Geometry. So, let's start with question 1 here. So, we have two polygons, P and Q, and it's asking us to select all sequences of translations, rotations, and reflections that would take polygon P to polygon Q. So we are taking this first polygon here, the blue one, and then we want it to end up where our green one is at. So let's look at our options. Rotate 180 degrees around point A is our first option. So if I rotate around this point, the main thing that tells me that this is not a correct answer is that the point that we're rotating around will not move. And that is at the tip of this sort of large pointy end of our polygon, and that would correspond with J. And so A is not going to actually end up where J is at, which means this would not work for our purposes. So this does not work. B is to rotate 60 degrees counterclockwise around point A and then reflect over FA. Well, A is here. 60 degrees would line it up here. So this shape is just going to swing down. And so this line here, B is going to line up with F when we rotate this. And then we're supposed to fold it over. But our shape actually isn't going to fold over the right way because A is still this long pointy end and it still hasn't moved, and I need it to fold over onto J. But really, the far side of this, once we swing it down, that far side is what's going to fold over towards J. So I know this won't work either. Now you could go through and try to perform all of these rotations, reflections, translations, but it is easiest to kind of focus on one item. So I'm going to be focusing on A and J. So that brings us to choice C, which is translate so that A is taken to J. And this is the first one that actually puts A and J in the same spot. So things are looking good. So translate so that A is taken to J. That means this line right here is going to move and is going to line up right here with this piece. So I'm actually going to draw this one so you can see it a little bit clearer. So if A is taken to J, that means that E, well, we're really moving in this direction, and it's like 2 units here. So I'm going to do the same thing with E and move it in that same direction 2 units, and it'll end up here. So that means we would end up with the shape here. This one would go here, and then we would have our shape come across like this. That's a line, or not a line, that's a curve. I want a line. There we go. So our shape's going to look like this. And then our second step is to reflect over line BA. Well, B is now here, and A is here, so this might be B prime, A prime. And yeah, if we're reflecting across this line, essentially, that is going to fold our shape over onto polygon Q. So yes, combination or yeah, our combination of transformations here is what's going to work for this. But it says all, so we still have to check D and E because D and E may also work to take this polygon P onto polygon Q. So I'm going to erase what I have on my diagram here just so that I have a little bit of a fresh canvas to look at my other two things here. So with option D, it's starting us out by saying reflecting over line BA. And then we're translating. So I have hope for this one as well, because BA in our previous one, we just translated along this line, meaning we didn't change the way it was rotated or anything, and reflecting across it worked. Since translations take lines onto parallel lines or onto themselves, it translated this line segment onto just another part of the line further down. So if we reflect across it, we should be still reflecting across that same line to start with. So I'm good with that reflection first. So this should work. And then translate by directed line segment BA. Now, if they tell us directed line segment, that means we know we're going from B to A, and it's just that distance, which is actually the same as if we took A and translated so that we land on point J. So D is also correct because it's the same as C, but it's just in a slightly backwards order. We're doing the reflection first and then the translation, but the outcome is still the same. We would end up with our shape just translating for the final step onto it. The last one is to reflect over line BA, so we're starting out okay, and then rotate 60 degrees counterclockwise around point A. Well, if I'm just focusing on A and J, that rotation's still not going to work, because if we're reflecting across BA, B and A are both going to stay in the same spot. So B and A are still both going to be here. And if we're rotating around point A, there's no way that point A is going to move onto J. That's just not going to happen. Rotating 60 degrees would still swing everything down this direction 60 degrees counterclockwise. We would just have a reflected shape first. So it's not a transformation that's going to work for us. So the only two that work here are options C and D. Okay, now let's look at question 2. The semaphore alphabet is a way to use flags to signal messages. Here's how to signal the letter Q. Describe the transformation that would take the left-hand flag to the right-hand flag. Okay, so I can see my left hand needs to come over to my right hand. So I think that I need to rotate maybe around the central position here of the arms. That would take this whole shape and land it here. So I'm just going to sketch that real fast with my red maybe. But the whole flag would end up looking like this after that rotation around that central part. It would still be a left hand flag and not folded in the right direction. So in order to get that to happen, we would need to reflect across this arm here. So let's describe the rotation first. So we could say rotate L. And if we want to estimate how far to rotate this, that left flag, in the stick figure's left hand, is about a 45-degree angle, because 45 is half of 90, and the person's right arm is making a 90-degree angle. It looks like this one's about half of that. So I'm going to say this is maybe 45 degrees, and this is 90 degrees. That means we're going to rotate both of those combinations there. So we're going to rotate L 135 degrees counterclockwise, because we're going to the left, so counterclockwise. Around. Now, we're going to say the shoulders / torso slash where the arms meet. Because that's really the central point here. We have a stick figure, so they don't really have shoulders. They just have where their arms meet. So we can describe it in one of those ways. Now, we need to describe a reflection. We can say, then reflect across, and in this case, that's still the person's right arm, so reflect across the right arm. A little weird talking about reflections and rotations on a person instead of on a graph, but still works, and we can still estimate some degrees here and everything too. Okay, let's go on to question 3. So on our next page here, we have question 3. We are matching the directed line segment with the image of polygon P being transformed to polygon Q by translation by that directed line segment. It's a little bit confusing the way they worded it, but essentially we're having a translation happen here, and they want us to identify what directed line segment works to make these translations happen. So I'm going to take a point on P and try to just see which translation or which directed line segment would move it to the corresponding piece on Q. So I'm going to look at the lower right corner of this larger part of the figure. And so I can identify that shape on both P and Q, and then I can draw a line that connects both of them. Now the difficult thing is that sometimes you may see just the two closed pieces here. So I'll zoom in on this one. You may see just these 2 points and think, oh yes, here, this is my directed line segment. But I need to make sure that I actually go and follow the red ones because those are the 2 pieces. So it sometimes helps for me to either highlight or circle the pieces that I'm looking to connect on my shapes. So I'm actually going to go put a highlighted dot on each of the corners here. I like to use green when I highlight, so the bottom right corner of each of these shapes, just even before I get started looking for any of them. And we do need to make sure that we are going from P to Q. So we are going from our blue shape to our green shape, and that's going to matter in the direction of our line segments. So before I even just choose options here, I'm just going to draw in my directed line segments. And the snapping on my tablet might not cooperate with me if it thinks it's too horizontal. But translation 4 is the one where it seems a little bit backwards because it's going to the left a bit. So I have my corresponding points and I have my now directed line segments input. Let's match them up. So for translation 1, that was a pretty long one and it's purely horizontal. So I would say that's D right here, that long horizontal one. And because they have this line in the middle here, I'm not going to do a matching thing. I'm just going to write the letters here that would match up with it. So translation 2, this one is to the right. It's mostly horizontal, but it's a little bit elevated. So that one looks to me like W here at the top. So translation 2 is going to be choice A. Now translation 3, that is right here on the left. So it seems to be going upward and to the right at a pretty decent angle. Looks to be choice B with directed line segment A right there. So this should be B, which means C should match up with translation 4. And we're still going to just double check. Does this line segment match up with this one? Looks like it does. It is short and then going down and to the left. So we have D, A, B, and then C for this question. That's the only question on this page because it's fairly large and you want to be able to actually see and measure up the sizes here. So let's flip the page. For question 4, we have another triangular grid. Our job, or what they're asking us, is to draw the image of quadrilateral ABCD when translated by the directed line segment V. So I'm going to highlight that here on my graph, just so that I can see it easier, and then I can kind of count how many units it appears to be going. So we're going to label the image of A as A prime, image of B as B prime, of C as C prime, and D as D prime. They're really just saying, hey, after you translate those points, please label them the prime variations of their names. So this looks like it is going 1, 2, and 3 units diagonally down to the right and following my actual grid lines. So I'm going to take each letter, and if we take A and follow it diagonally down to the right, 1, 2, and 3 grid lines, that would put it right here just below C. So I'm going to put my point here and label this A prime. And we're going to do that same process with all 3 of the other shapes here. I'm sorry, or the other points that make up this shape. So from B, we're going to go 1, 2, and 3. That would put us right about here. So here. Now you can use the points in relation to each other because these 2 segments will maintain their length and also their rotation, since this is just a translation. But sometimes it's useful to just follow your directed line segment for each of these things. So if we follow that directed line segment for point C, we should end up here. Oh, I should actually label B prime, so B prime and C prime. And then last but not least, if we follow that directed line segment for D, we should end up here, prime. And now let's label, I'm sorry, not label, let's connect our dots and draw our whole polygon, not a curve. I just don't have a steady enough hand to draw a straight enough line, apparently. And there we go. That's what our polygon should look like. I'm going to draw in the directed line segment will probably be best visible from B to B prime, since it's not going to hover over anything else. And I can kind of highlight that here too, so that you can see where that was applied to the whole shape. Okay, so on to question 5. Oh, we have a line, L. So, our instructions. Plot 2 points A and B, which stay in the same place when they are reflected over L. Plot 2 other points, C and D, which move when they are reflected over L. Well, when we reflect something, that means it creates a perpendicular bisector between the image and the pre-image. But if I have, that's an eraser, if I have points that lie on top of the line of reflection, they're already in that spot, and so they're not going to move when we reflect them. So I'm going to say that my 2 points, A and B, which are going to stay in the same place, are going to be these points on the line. And then if I want 2 points that will move, I can just put them literally anywhere that's not on my line and say this is C and D. And that's it for question 5. So let's keep going. We're on to the next page here. Actually, the next page is a different assignment. So I guess that means we're done for this portion of our packet. So that is then it for this video. This was Unit 1, Lesson 13, the cumulative practice problems of illustrative math geometry.